And we're live. Welcome everybody. It's Average Code 2022 day 14. See, my Christmas tree is still broken. I should be able to fix it this evening, so hopefully it's up and ready for day 15. But anyway, let's go into day 14. Here's my coding environment. Check out I have all my files. Yep. Right. And I'm ready to begin, so I'll see you after the time lapse. Oh yeah, I had a bit of an issue with my input for part 1, which you probably saw here. I think it was just the way that I copy bit and Vim worked. I don't know, something weird happened. Sent me back a couple of minutes. Really annoying, but oh well. Yeah, I had to re-download the file and redo all of that stuff. But yeah, that's what you see here. That's why I kind of messed up at the beginning. But anyway, hope you enjoy. Right, that's part 1 done. Took a bit longer than I wanted, but that was such a weird problem. Really like that though. My code's really janky. But well, we'll move on to part 2, and I'll see you after the time lapse. That's part 2. Yeah, part 2 was pretty quick again. Awesome day. Yeah. Again, I love these puzzles. They're just so great. Anyway, let us look at the question. Day 14, Regolith Reservoir. Here's the alliteration again. What does regolith even mean? Oh, it's a type of rock. Oh, I think that's like the stuff you get on the moon. The distress signal leads you to a giant waterfall. Actually, hang on. The signal seems like it's coming from the waterfall itself, and that doesn't make any sense. However, you do notice a little path that leads behind the waterfall. Yeah, there was literally no value to this word being bolded. Correction. The distress signal leads you behind a giant waterfall. There seems to be a large cave system here, and the signal definitely leads further inside. As you begin to make your way deeper underground, you feel the ground rumble for a moment. Sand begins pouring into the cave. If you don't quickly figure out where the sand is going, you could quickly become trapped. Unfortunately, your familiarity with analyzing the path of falling material will come in handy here. Wow. I love it when he links back to earlier days, because it's going to give people who actually did these days just so many backflashes. I don't think I ever did this day. Yeah. Anyway, you scan a 2-dimensional vertical slice of the cave above you, your puzzle input, and discover that it is mostly air with structures made of rock. Your scan traces the path of each solid rock structure and reports the XY coordinates that form the shape of the path, where X represents distance to the right and Y represents distance down. The classic Chomsky Cartesian plane. Yeah, because in maths, I guess Y would represent going up, whereas here Y represents going down. Each path appears as a single line of text in your scan. After the first point of each path, each point indicates the end of a straight horizontal or vertical line to be drawn from the previous point. For example, blah blah blah. Sand is pouring into the cave from point 500 to 0. Sand is produced 1 unit at a time, and the next unit of sand is not produced until the previous unit of sand comes to rest. It sounds like a physics problem now. A unit of sand is large enough to fill 1 tile of air on your scan. A unit of sand always falls down 1 step if possible. If the tile immediately below is blocked by rock or sand, the unit of sand attempts to move instead diagonally, 1 step down or to the left. If that tile is blocked, then the unit of sand attempts to instead move diagonally, 1 step down and to the right. Sand keeps moving as long as it is able to do so, at each step trying to move down, then down left, then down right. If all 3 possible destinations are blocked, the unit of sand comes to rest and no longer moves, at which point the next unit of sand is created back at the source. So drawing sand that has come to rest, blah blah blah. Using your scan, simulate the falling sand. How many units of sand come to rest before the sand starts flowing into the abyss below? Yeah, so again, reading this doesn't give you too much information. I mean, it is a question, so it's still good to read it. I kind of just gave up and decided to read everything. And yeah, that made sure I got a really, really crystal clear picture of what I meant to do. And I think the examples just really helped with that. And the fact that, this somewhat aligns with your common sense of how physics works, right? Because sand tries going down, but if it's, not possible, it goes down right. It's like if you were to visualize this, sand kind of coming down in, like a pyramid. Pretty hard to visualize with my hands, but you can kind of get the idea here. So it does look realistic, so it wasn't too hard to understand. But yeah, let's look at my solution. Oops, what did I do? Did I just close my tab? Let me just reopen that. Right, now let's look at my solution. Bear with me. There you go. Okay. Vim day 14a. Right, so I guess the idea of my program is I basically have a set, and that keeps track of every coordinate that's currently filled with something. So it keeps track of every coordinate that is filled with a rock, for example, and every coordinate that's filled with sand. So initially, every filled coordinate is just going to be a rock. That's what I do here. I just pass through the input, and I just every coordinate that's rock I add to a set called Q. Yeah, you can probably try and figure out exactly what this does yourself. I'm not going to go through it here. But one of the logic errors I had was this bit, because basically if you're moving from a position of high to a position of low, then you'll be kind of moving downwards. So if you're moving from 500 to 400, you're moving downwards. But obviously by default, for loops go upwards. So like that for loop just wouldn't run because you're moving downwards, and therefore, as far as the for loop's concerned, you've already run. And so what you have to do is just start with the minimum x and then go to maximum x. And same for y. Start from minimum y and then move up to the maximum y. You could probably have done this another way just by figuring out if you're going down, and if you are, then just like go down -1 like that. But I just thought this was easier. Yeah, that's what I do. So this is every coordinate that there's rock, essentially. Then that's the input. Right. You can ignore the sleep thing, that's just to help debugging. And then S is the initial amount of rock occupied, because the idea is, at the end, my answer is going to be how many coordinates are occupied with something. But that something can be one of two things. It can be sand or it can be rock. But I only want to count how many sand particles are there and not how many rock particles are there. And so what I have to do is I have to know how much rock is in there in the first place. So at the end, I can subtract the amount of rock that was already there. That's what S is. And then this is the actual program, I guess. Yeah, so basically just infinite loops, nested infinite loops, like here. And your source is just going to be AB. AB here just represents your coordinates. It's like A is X, B is Y. And then forever you keep simulating the sand going downwards, and then so like this is the sand going downwards, this sand going down left, and this is sand going down right. You just simulate that, and you keep doing that until you can't. And then if you can't, then it'll automatically run these two lines. And what that does is it just says, okay, my sand is now at rest, so I'm going to chuck it into my set of occupied blocks, and then break out to this loop, and then continue with the rest of the loop. Right, and then what this logic does, this logic is just there. I mean, this is kind of like an arbitrary number I chose, but it's essentially saying, if your sand has moved 10,000 steps and it still hasn't stopped, then I'm just going to assume it's falling into the abyss. And at that point, if sand's falling into abyss, then all sand after that's going to fall into the abyss. And I guess that's kind of the thing to notice in this problem. The first time sand falls into the abyss, every sand particle from then onwards is going to fall into the abyss. I guess just kind of try to look at the input and try to figure that out, but that's just how it works. And so you're saying, as soon as the first sand falls into the abyss, you know the rest are, and therefore you've already found the maximum capacity of sand, which is just going to be the amount of occupied coordinates minus the amount of coordinates you started with, so the amount of rock. And this answer will just be sand. And yeah, that's pretty much it. Similar logic here as well with like these continue statements, because I'm saying, oh, if I can already move, I'm just going to continue the cycle. So if I can move somewhere, I'm going to move there, and then I'm going to go back to the start of this while loop. And the reason I have that is because these continues effectively just reset the while loop. But so if these continues aren't run, then the while loop is not reset, and therefore these two lines are run. And that's important because continue is only ever run if there's a valid move to be made. So if there's no valid move to be made, then continue is not run, and therefore these two lines are run. And these two lines are the lines saying, okay, my sand is now at rest, and therefore there aren't any more moves. But yeah, that's kind of what the code does. Pretty simple, really. Yeah, just keeping track of every coordinate where there's something there. And then you just simulate all the sand going downwards. As soon as the sand can't move anywhere else, you chuck that into the coordinate list, and you continue doing that. And then to find your answer, you just check if the sand has fallen down like 10,000 times. And if it has, you just make the correct assumption, that it's fallen into the abyss. So I guess that was a bit of a sketchy part of my program, like this assumption bit. Because obviously if there's a really big cave, then I guess 10,000, it could feasibly fall 10,000 times and then eventually settle. But I mean it didn't, which is great for me. Right, so let's move on to part 2. I feel like there's something wrong. Okay, oh well. Yeah, there's something messed up with my Linux setup, so I'll fix it afterwards. But part 2. You realize you misread the scan. There isn't an endless void at the bottom of the scan. There's a floor, and you're standing on it. Really? It's such a classic mistake. You don't have time to scan the floor, so assume the floor is an infinite horizontal line with the y coordinates equal to 2 plus the highest y coordinate of any point in your scan. Here's an example. I didn't actually read. Oh well. Using your scan, simulate the falling sand until the source of the sand becomes blocked. How many units of sand come to rest? Yeah, so I mean, it's a pretty similar question. You can just read this sentence and then read like this sentence, this paragraph, and that's all I did actually. I didn't really read any of this example bit. I didn't read any of this. I kind of forgot it existed, to be honest. And that's just because here, like, the question's so clear, it's so short, it's so easy to understand, that I just didn't feel the need to read it and waste time. But anyway, the algorithm is going to be pretty much the same, right? And you see most of it is the same. But you now need to do two things. The first thing is now find where the floor is. So to do that, I just have t, which is my maximum y coordinate, and then I keep updating it to find the new maximum y coordinate. And then, yeah, I find my maximum y coordinate is t. And, I mean, it says that the floor is 2 plus the highest y coordinate. So I'm just adding t plus equals 1. I will admit now, I'm pretty sure I've meant that to equal t plus equals 2. But the correct logic is t plus equals 1, and I'll tell you why later. So this is like the maximum y coordinate of where each sand can fall down to. It's like, this is the maximum y coordinate that any given sand particle can be at. And I guess that's why it's correct to do plus equals 1, not plus equals 2. Yeah, I just made a typo there, which thankfully was correct and got me the solution. Yeah, the rest of this is the same. And then you see like a few changes here. Firstly, like, I don't really care about finding this abyss thing anymore, so I just commented out those lines. But the real change is this line. And what that line is saying is basically, if the sand particle, so basically each sand particle starts at the particle generator in this coordinate system, like a 500 0. So you're saying if that coordinate is already in the set of occupied coordinates, then you found the answer, right? Because the question is asking how many sand particles do you need before your thing is blocked, and this checks if your generator is blocked. That's what that line does. And then the other bit I needed to add to this were these 3 lines. And these basically just check if you reach the maximum y coordinate the sand can be. Because at this point you can keep going down, but because of what the question says, you can't keep going down. You can only go so far down. So your y coordinate can only go down to t. And that's why I check it. I'm saying if your y coordinate is the maximum possible value it can be, then I'm just going to add that to the occupied coordinate list, and then just break out and simulate the next piece of sand. So yeah, I don't think there was too much to add for part 2, which is really nice. Quite like those. Just small modifications and trying to think of the best way. I quite like this. But yeah, that was my code, and yeah, I'm pretty happy with that day. I think no real specific algorithm or specific really tough implementation. It's just trying to think of the logic and then implementing it, which I quite like those problems. It's less so, oh, I remember these 5 algorithms and now I know exactly which one to apply. It's not that. Like, you know, if you remember graph algorithms, it's not that. It's just great. Forces you to think for yourself as opposed to just copy down the same algorithm you've learned. So yeah, nice day. And that brings me up to 28 stars. And yeah, the calendar's finally doing something. And yeah, you saw what I said yesterday. I thought this would be a waterfall, but obviously it was a waterfall, which is great. Yeah, I guess that's the bottom of the waterfall. That's like where the water falls. Since this is going downstream, right? This is the river. Like, this is the sea. So that means the waterfall is falling this way downwards. So that'll be like the foamy bottom part. That would be like the vertical part where the water falls. And that, I don't know, is that the cave? Wait, yeah, because the water comes out of the cave, right? Saying little part that leaves behind the waterfall, which is a cave. Yeah, so I guess that's the cave, yeah. Or, I guess that's blue though, so it looks like water, so the cave will probably be drawn on the next one or something. I don't know. This is quite cool having a calendar though. And all this left side is being filled up. It's quite nice. Don't know what's going to be here on the right side though. It's going to be some random monster you suddenly found. Something like that. Anyway, leaderboard. Okay, 10.5 minutes, and 5 minutes. Yeah, really fast again. I think I was yeah, definitely had to reach this leaderboard. No, I would have gotten that. They were fast. Let's see what part 2 is. 6 minutes and 14. Yeah, so like another 3 minutes it seems for people to do part 2. Which is really good speed there. But I see everyone kind of read the code in a way that could be really quickly modified for part 2, which is nice. Let's check out the stats. Ooh, day 7 is getting so close to 100,000 people doing it. I'm assuming that day 7, that's like the hard day where you have recursion in the DFS. Or like, you could have done it another way, but recursion in DFS is the most common way. I think it's great to see more people do it because it means people are going to be learning how to do it. That's why it's taking a while for it to catch up. That's nice. Today, yeah, it's been dying down in recent days. I guess it has been getting harder, and of course people tend to lose interest if it takes more than like half an hour to do, which is fair enough. But yeah, a lot less people are doing it now. Check out my private leaderboard. Yeah, again, loads of people racking up all of these stars. There hasn't been a really tough day filter yet for our school to filter out a ton of people. Yeah, I mean, the delta times were pretty fast. Yeah, I had a good delta time. Avnas was even faster though. Oh, Nanos was just slower. Were there times? Yeah. Pretty spread out, but I think, yeah, Avnas delta time kind of brought them a bit together. But I think this is going to be the general trend. Like, it's going to be anonymous first, it's going to be Danish, then it's going to be Avnas. But yeah, fair play to them. Mr. Ghoul's really late. Did he not just... I don't think he woke up on time, surely. Yeah, anyway. Aiden just bagging all of these golden stars. Good job to him. And yeah, I mean, the gap between Abhinav and Danish is really small. It could flip at any, like, given 2 days. So I'm interested to see how that plays out. But anyway, that's AoC 2022, day 14. Awesome day. I loved the sand simulation, that was really fun. I suspect there'll be some really nice visualizations on Reddit, so I'm going to pop off right after this and look at those. Probably a couple of Minecraft ones, a couple of terminal ones, as usual. Maybe someone even 3D printed something, I don't know. But yeah, awesome day, love the puzzle. Hopefully you enjoyed that, hopefully you got your own code to work, hopefully you also found that pretty fun. And thanks for tuning in, I'll see you tomorrow for day 15.